We are on page 602 in our book, and we are going to finish up lesson 9-2. We touched on these, or the first of these problems in class today, but we need to look at a couple of them and look at it in a little more depth to make sure that you understand it for your homework. So again, lesson 9-2, page 602, example 3 at the top of the page, finding the area of regular polygons. I want you to look at the polygon that they have shown us. And I'm going to talk you through how we do this. We are told that this is a regular hexagon with a side length of 6 meters. So we know that every side, because this is regular, is going to be 6. We also know that that means that we create 6 triangles in this polygon. And we also are able to figure out what our central angles are by saying the 360-degree circle in the middle divided by 6 central angles is 60 degrees. So we know that each of these angles is 60 degrees. What we don't have all the pieces of the puzzle to do is to solve for the area of this triangle, and we must do that in order to be able to solve for the area of the whole polygon. When we draw our apothem in this bottom triangle, you can see that it splits it into 2 right triangles. And because we know that the central angle is 60 degrees of this triangle right here, sorry, Clayton was sending me a message. Because we know that this is 60 degrees, we know that half of it at the top of this smaller right triangle is 30 degrees. That tells us that this is a 30, 60, 90 triangle. So we can use what we know about 30, 60, 90 triangle sides. When you look at a 30, 60, 90 triangle, you know that the short side is x, the longer side is x radical 3, and the hypotenuse is 2x. So now let's apply that to the little right triangle whose shorter side is 3. Now that is just half of the whole side length that we were given. So if this is 3, then the apothem is going to be 3 radical 3, and the hypotenuse would be 6, or 2 times 3. But the apothem is what we really need here. So just as the longer leg here was x radical 3, the longer leg here, or apothem, is 3 radical 3. So now that we have the apothem, or the height, of this bigger triangle, we can solve for the area of it. The whole base of it is 6, which is the side length of this polygon, and we say 6 times 3 radical 3, which is 18 radical 3. You'll see that right there. Half of the base times height, or half of the side times the apothem. But we haven't taken half of it yet, so now that's 9 radical 3. The base times height, or side times apothem, was 18 radical 3. Half of it is 9 radical 3. That tells us the area of the triangle. And now to find the area of the whole polygon, we must multiply it by how many triangles there are in the polygon, or how many sides there are. So 9 radical 3 times 6 is going to be 54 radical 3. And we plug that into the calculator and find out that is 93.5 meters squared. All right, the next problem we need to look at is letter B, and it tells us a regular pentagon with a side length of 8 inches. Oh, y'all, I'm so sorry. I'm trying to slide that across my book. There we go. Okay, y'all bear with me. Let's look at our pentagon with a side length of 8. All right, we're going to need to take the exact same approach. The only thing they told us in this problem was 8. Everything else has been figured out since then. So let's start from scratch here. We know that if this is an 8-inch side length, that all of these are 8. We also know that because this is a pentagon, that there are 5 sides and therefore 5 triangles. So let's start by figuring out our central angle. We would need to say 360 degrees divided by 5. You'll see that right here, the 360 degree circle in the middle divided by 5 triangles, each with a central angle. So 360 divided by 5 is 72 degrees for each triangle's central angle. So just to keep that straight, I'm going to put it right there, 72 degrees. Okay, But now when we draw our apothem in this bottom triangle, it of course splits the triangle in half, creating a little right triangle for us, actually two little right triangles. And when we split the central angle measure in half, we find out this is 36 degrees. Well, we have an angle measure and an opposite side, but we don't have anything else to figure out our apothem. So we're going to need to use tangent. Tangent being opposite over adjacent, so we're going to say the tangent of angle 36 equals the opposite side, which is 4, over the apothem. We'll solve for the apothem. We'll multiply both sides by it, and then divide both sides by tangent of 36, and we'll have apothem equals 4 over tangent 36, which is apothem equals 5.5. So we find that our height or apothem here is 5.5. Now we need to find the area of this smaller triangle. The whole base is, of course, an 8. And for area of that triangle, we're going to say area equals base times height, or side times apothem. And that's going to be 1/2 times 8 times 5.5. And that gives us 11. And then, so that triangle's area is 11. Now we must multiply that by 1, 2, 3, 4, 5, because there are 5 sides or 5 triangles in this polygon. And once we do that, we get, hold on, I didn't do that right. That's the second time that I have not done this right and that I have started over on a video. So y'all bear with me for just 1 second. Sorry you're having to wait. So I'm saying the apothem, which is 5.5, times the base, which is 8, equals 44 divided by 2 to get the area of this triangle, and that is going to be 22. And when we multiply that times 5 triangles, we're going to get 110. Don't know why I have an 11 right here. That should be a 22. So I apologize for that. And when we multiply that by the 5 triangles, we get our area of the whole polygon, which is 110.1 inches squared. All right, I hope that helps. Here is number 3 to check it out. I'm going to turn my phone sideways and just show you my work from it. And that way, if you want to try it, that gives you the answers to look at and to see how I solved it. And that might be helpful to you. You can pause the video and look at that and try that before you move on to the homework. All right, that's it. This is the only video for lesson 9-2. I hope that was helpful, and I hope y'all have a great day. Bye-bye.